Okay, so you guys see 6. So the question is to solve the system. So we need to solve the system by substitution. Not some other method, but the substitution method. We have different methods. We have graphing. We have graphing, we have elimination, and we have substitution. So now we're doing substitution. So I'm going to open the whiteboard and I'm going to write down this system and then solve it. So let me share my whiteboard with you. All right, so so 4.2, question number 6.
6.
All right, so solve by substitution. And the system is we got x plus 3y y equals negative 5x. All right, so I have a system here which is made of 2 equations. We have one equation and another one. They're tied together with this curly brace. That's what makes this a system, okay? A linear system. It's called a linear system because both equations are, each one of them is a linear equation or a straight line. Together they form a system. So these lines may, they could intercept. It could be intercepted in one point. In that case, that's the solution. Or when they meet, basically we just get the coordinates, for example, x and y of this s. S is a point, so we write the solution as x and y. That's when you solve by graphing. These lines may also be parallel. In this case, there's no interception, therefore no solution. Or they could also overlap. When you graph the 2 lines, they end up like this, one over the other. So in this case, we have many solutions because basically the lines meet everywhere, all these points, and the lines extend infinitely. A line by the definition is an infinite number of points, extend infinitely. So in this case, we have many solutions. That's when you solve by graphing. But we're not solving by graphing. We're going to find the solution by a method called substitution. It's an algebraic method, involves solving without a graph. But regardless of the method you use, the solution should be the same. And again, when you have a system of 2 linear equations, the lines could meet. When they meet, the intersection or interception is the solution. The lines could be parallel. In that case, no interception, therefore no solution. Or the lines could overlap. In that case, we have many solutions. That's by graphing. But now we're going to solve by substitution, and we're going to get to one of these results. Okay, let's figure out how to solve this by graphing. So everybody, can you guys hear me? You hear me well?
Yeah.
Okay, very good. So I'm addressing everyone. I'm addressing everyone. So please feel free to engage and participate. All right. So so the substitution method. Substitution means to replace. Okay, Leilannette, I see your question. I'll address it after this one. Okay. So substitution, to substitute something means to replace. So basically when you go to the equation, you look for the variable that's by itself. The variable that's not the variable or the unknown. Okay, we could call it variable because the solution could be many solutions, so it varies. So we go to the letter that's by itself, and you plug it into the other equation. So here, we're going to go over here and plug that into this equation. So y is by itself. We're going to plug it into the other equation. So you look into the two equations and you look for the variable that's by itself. If you don't have a variable by itself, then you have to isolate it. Let's say we didn't have y by itself here. You could isolate the y, the x here, by moving this over. Once you get the x by itself, then you can plug it into the other equation. But luckily here we have a variable that's by itself, so we're going to plug y into y here in the equation. So we have, you can call this equation 1 and equation 2. And so plug y or substitute y into equation 1. So substitute y in equation 1. So this y here will be substituted. So we end up with x plus 3 times y times this y, which is, so instead of the y, we're going to substitute the value of y.
Minus 5x.
Exactly. And the rest of the equation should remain the same. We're only removing the y, and we substitute it with this. The rest, x and this, should stay. Once you do that, you see that the equation has only one variable, now only the x. That's the reason we substitute, so we can get rid of one of the variables. Instead of having x and y, now we can solve this easily. Only has one variable, that x here and the x here. So solve for x. All right, so how do you solve this equation for x? What's the first thing you do?
The parentheses first.
That's right, we need to distribute.
It's minus 15x.
That's right, so negative 15x. And
equals to minus
20.
Minus 20.
That's right, we need to continue to get the x by itself. We can combine these two terms. Basically, think of this as 1x. So
14
1 minus 15.
minus 14
Minus 14x
That's right, negative 14x
equals negative 28.
28. All right, let's get the x by itself. What do we do to get the x by itself?
You have to take away
Divide
the
it.
14.
That's right, we're gonna need to divide by,
14 minus 14.
that's right, we're gonna divide both sides by negative 14. So these cancel out. X is negative divided negative is
Positive.
positive. 20 by 14, that's 2. That's half of the solution. As we said earlier, the solution, if it exists, is a pair of two coordinates, the x and the y. So we found x, now we need to find the y. So it looks like the lines are going to be intersected. Since we found one solution, so we have half of the solution here. They're not parallel, they're not overlapping. So we have x. Now we need to find y. So how do you find y knowing the x? Look at the system here. We're looking for the y. We know the value of x. What do you think we do with x in one of these equations to
You
find?
use the first equation?
Why would you use the first one and not the second?
Oh, that's true, because it's by itself. Yes, you're totally correct. You use the bottom one.
That's right.
And x is 2, you multiply it.
Exactly. So
You have your answer,
we're
10.
looking for the y. The y is already isolated here. So it would be convenient to just take the x2 and plug it into this instead of this. If you plug it into that, it will be the same thing, but this will take more steps.
Yes.
And the y here, you will have to cancel x, cancel 3, so it's more work. This one is easier. I'm just going to write the equation. So y is negative 5x we do know the x, we just need to plug it in. So the x is here, goes
Two.
into that. That's right, so x will be,
-10.
that's right, -5 times x. And the y is -10. That's it. Once we find both x and y, so the solution is done. So what do the lines do? Do they meet, are they parallel, or do they overlap?
I think it's parallel. I could be wrong.
So we found one solution, right? One intersection. So the lines do what? The lines meet. Okay, that's basically this case. So the x, we have the x here, which is 2. We find the y, which is -10. If they're parallel, there's no solution. They will not meet. You won't be able to find x and y. It will be some weird solution. If they're, I believe we did a couple of examples like this before. If you go back to the videos that I posted on YouTube, you'll see that we discussed examples like this. There was a case where the lines were overlapping. We said many solutions. And also we talked about this when the lines are parallel. In this case, we have one solution, S. So the point to -10. So we found the solution without graphing, okay? Because the question said solve by substitution. If the question was solved by graphing, if you graph them, you'll see that they meet here. If you do the graph, you'll see that the lines will meet on this point. Say if we had this graph, 2 -10 would be something like this. So the point is here. So this is the point, 2 -10, the x is 2, okay? It's the x-axis, this is the y-axis, and this is -10. So the lines, when you graph, that's the point. So these two lines, if the question was by graphing, when you graph them, they will meet here, something like this. But again, we use the substitution to solve the equation. So that's basically the solution. One intersection, one point of intersection. Okay, so this is the solution. Does that make sense to everybody?
Yes.
Yes. Thank you, Professor.
All right, no problem.